right, OPO.js, woo! All right, so the other thing is I'm extremely jet lagged still after being here for like 4 days. So yeah, we have to get excited, and it's security, and I know it's really exciting. Actually, it can be really boring and dry. So I'm going to try to make it exciting and get animated. I really hope that this tether that I have on me doesn't stop me from like moving, but hopefully we'll be fine. So for those of you, first of all, I'm going to talk about node security. I'm Adam Baldwin. I'm not the actor Adam Baldwin. Did not star in Firefly or Chuck. You can find me at Adam Baldwin on the internet, or Twitter. That's the internet, I guess, too. And GitHub, Evil Packet, where there's some like crappy code there. I work at a place called And Yet with David and an amazing team of people that we build software. We build stuff with Node. Who else builds stuff with Node here? Please, lots of hands, because then this won't get awkward. Okay. So we build web software and cool stuff. On the other side of the house, which is the side that is where I focus most of my attention on, is the Lyft security side. That's David as well, right there. We climbed a big hill together to take a picture, silly selfie. And we on the other side we break software, right? So I get the privilege of looking at a lot of developers' code and a lot of Node projects and a lot of other platform projects, and pointing out flaws in those and finding flaws in those. And it's my passion, sort of like pointing out all this stuff and finding this stuff. About 3 years ago, I started a project called the Node Security Project. Has anyone seen anything about the Node Security Project? A few people? Cool. Awesome. Yay. That's good, because we're going to talk a bunch about that towards the end, and sort of talk about some of the goals. Well, I'll do that now. We'll talk about the goals of the project. So I started this to basically evangelize security within the Node community. The problems that I'm going to talk about today have existed for since the dawn of time, right? These problems related to security are not new to the Node community, new to JavaScript. They've existed back, in the C days, back in the Perl days, with CPAN, with Python and pip, and Ruby and Ruby gems. These problems are prolific across all of these platforms, and so I wanted to change the perspective when it came to Node. I was like, all right, damn it, this is enough. We're going to change it, and we're going to try something new. The Node Security Project is basically, I'm a hacker and I like to try experiments, and so that's what this is. This is an experiment on the community. I'm sorry you've all been a part of an experiment. Today, that's not there. Today I'm going to, since I like to evangelize security topics, and I don't often talk about this in depth. We're gonna do a review of the OWASP Top 10. Who has heard of the OWASP Top 10? That's more hands than I normally see, which is good. So for you, this is going to be a very quick review, but I'm going to try to give my spin on it, the patterns that we see auditing Node apps when it comes to the OWASP Top 10. During that, we're also going to get sort of like a little peek at the Node Security Project tools, things that can help you utilize the Node Security Project, as well as, and then at the end, we're going to talk about the really fun stuff, the stuff that I'm really excited about, and that's security in the Node ecosystem, and sort of what we're doing with the Node Security Project most recently. Without further ado, the OWASP Top 10 and review for like 12 people in the room. So the first one, so the OWASP Top 10 is a set of common flaws, like the most common flaws that exist in applications and web applications, and we see them all the time. It's by far not the entirety of the security problems you're going to see in an application, but if you target understanding the OWASP Top 10, you're going to have I guess a better time with application security. You're going to find flaws, and you're going to have a more secure app. So the first one is injection, and this actually has to do with SQL injection, NoSQL injection, like OS command injection, where you're able to take data from a data source, data input, put it into your application, and it ends up injecting into some other subsystem. And that's a secret right there. The sort of dirty little secret of the penetration testing community is that's really all we do as at Lyft. We find data sources, we look for data sinks, and we see where the data traverses. And this is a big area, and this is why it's the #1 on the OWASP top 10, is that when these actually exist in an application, they are extremely like they have large impact. And so one of the ones that we've been seeing lately is with Express and Mongo. And specifically, like, we see that combination a lot. We see Express apps, Mongo apps, data flowing from one to the other. And so and we see this particular assumption being made. So when this happens, qs.parse foobar.baz, what would you expect it to produce? If you know the actual answer. Is it going to just produce a string? Is it going to produce, like, what would be the result, right? So you're going to get an object back that's going to look like this. But most of the time we want like value or key value, right? Just like David was talking about, key and value. That's typically what we want. But QS and that's only because of this structure here. And so normally you might say, if we have say something like a Mongo database, and we parse something like this, where you got an ID and you got a not in and you got a value, you can create a really complex object with your URL query string, and that ends up in your Mongo database. So if you put this in a find query for, say, authentication or something like that to retrieve data from a database, you're going to end up with, you can do really complex queries. Say you end up with a regex query or something like that, and you might be able to pull out data that you shouldn't have access to or something like that. So that's, oh, by the way, I forgot to say, I'm going to go really, really fast. So if you're interested in any of this, you can go to OWASP.org and get more in-depth information regarding each one of these. The second one is broken authentication and session management, which basically has to do with things like not properly hashed passwords, because everyone stores passwords in clear text, right? Like, that's a thing. We actually see that on tests. People laugh, and developers do that. So if you're doing that and you know about it, don't laugh, change it, because we see it. Like, I hate to sound like I'm shaming, but we see it. We actually do see it. And this is partly too about protecting things like session identifiers, so cookies that deal with sessions, and things like HTTP only flags on cookies. So an HTTP flag on a cookie basically says that the JavaScript on the front end, the JavaScript that you want to write, can't consume that cookie, can't actually have access to the cookie and just able to send it. So as well as SSL for data in transit, which is this particular category. So moving on, cross-site scripting. Probably everyone knows what that is, right? Number 3, cross-site scripting, super prevalent in web applications. We're definitely seeing it less in the apps that we audit because of frameworks, because of templating languages that actually give good defaults. This is sort of a table of escaped values and unescaped values. And you can do yourself a favor when you're when you're writing an application. If you search for any one of these sort of, it's kind of hard to see, but you've got, like, there's only little values that differ between an escaped and an unescaped. And you have an insecure situation here potentially. And if you just search for these patterns, if you search for triple mustaches, if you're using mustache conveniently, curly brackets, whatever, just grep across your entire code base, you're going to see all the instances using that, and potentially you've got an injection point. For those who aren't familiar with cross-site scripting is when you take user input and it is basically reflected back out from stored from the database or from the query parameters in the URL, put back into the browser, and that then is rendered in the DOM instead of displayed. So a script tag might might execute, and then it's basically the same as if I gave you a piece of code to run, as David's example, floppy disk, which we use anymore. If a USB stick and you just run an executable, it's code execution in your browser, which the browser is the operating system. There's a couple other instances that are really interesting. Mustache with register helper. Safe makes strings basically safe by default, so that's an injection point, as well as handlebars safe string. Any of you using Ember and Ember helpers that may use safe string, you may have to escape that data by default afterwards. So I'm going way too slow. So insecure direct object references. Something that we see here, basically this is where a developer exposes a reference, like a URL or something like that, and basically you can access it just by changing an ID or changing a value, right? You can flip that reference and just tick 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 and walk through them, and that's basically it. You always have to check and validate that somebody actually has access to that resource before you render it back out. It would be something like this, just saying send back the data when we find it with just whatever ID was in there. We didn't actually check there was authorization there. We see this quite a bit, and we see this stuff protected instead of good authorization code. We see it ended up being protected by say just random values. And those random values then, instead, what we do then is you go back to the first slide where we can create complex queries out of the query string, and we end up getting around the fact that we can't guess that value. So it's useful. Same thing with like just reading something off of disk and just sending it back to the user. You can have a directory traversal where you just // move yourself way out of the root where you're reading files and display it back to the user. So that's that. Security misconfiguration. This is basically just like, this is OWASP's like, we're just going to dump a bunch of crap in a category, which is just, it comes down to, though, insecure defaults, and which the most useful piece out of this that I can tell you about is security headers. There's a bunch of security headers you can put in a web application. If you're using Express, you can use Luska from PayPal or Helmet to just add these security headers really simply. If you're using Happy, it's actually built in by default, and you set security yes, and you get, I think, all of these but content security policy. And I'm not going to go into content security policy, but if you're building web applications, go learn what that is and implement it, because I think it's a great set of defaults for combating cross-site scripting type vulnerabilities. Sensitive data exposure. Again, security when it comes down to this is usually about security of data in transit, in use, and at rest. So in transit, SSL, right? At rest, we want to make sure we've hashed passwords in a secure way. The current trend is to use bcrypt or scrypt, depending on what type of attack you're trying to protect against. And the other thing we see a lot of is just like YOLO logging, console log request.payload, and just storing it somewhere and doing this in production, and on forms that take credit cards or other sensitive information, and that ends up putting that data in some just log file that gets stuck someplace that we can have access to then if we happen to get into a logging machine or something like that. Missing functional level access control. This gets confused with direct object reference a lot, and it's related, where this has to do with authorization as well. Basically, it has to do with checking permissions before you give somebody access to something. Again, I feel it's basically the same. There's some nuances between the two. I'm not going to explain it because I think it's the same as the other one. Cross-site request forgery we see a ton of. And I'm gonna go into detail on this one because it is so impacting. Cross-site request forgery. I didn't do really complex slides, which I could have, but all of this stuff has way better explanations than I can give you in a very, very short time. Cross-site request forgery exists when you. Okay, back up. So imagine you're submitting a form to change your profile, and it's just a simple web form. And when you submit that form, you change your email, and you submit it, and it sends a post request to some URL, right? And then your email's changed. As an attacker, when you visit, say, evil.com, and I can have that same form existing without being visual, and I can submit that automatically with JavaScript, and then I can change your email address. And so there's only really one way of preventing that, and that's where you include a secret token on render. So when I render it on example.com, I put the server's going to put a token in there. Evil.com's not going to and check that server side when it's submitted. Evil.com's not going to know what that token is. A lot of apps get get saved by using they use the separation of an API and a rendered application where you're using something like a bearer token to do authentication when you have to send those to the API. If you're doing that through a header, it's only allowed on that domain. You've kind of killed two birds with one stone, because a remote attacker won't have that value and it won't get submitted to that API. The one place that we see this really, really missed is with WebSockets. When you build a socket.io connection to another server and you end up doing authentication using cookies. And that's the secret sauce of why CSRF works, is because the browser says, oh, you'd like to send a request to this other domain that you already have authentication credentials for, and it just sends those cookies along for you. Oh, we'll just tack these cookies on it, and it goes with. Socket.io's built-in data authorization handling basically uses cookies. And so if you don't actually send some type of token over the pipe, or you don't put it in the query string or something, and if you put it in the query string, then you end up with the sensitive data exposure problem, so they kind of go hand in hand. But if you don't send something over the pipe, you end up with a CSRF type issue as well with WebSockets, and we see that actually more than traditional because of the new APIs, the style with APIs. Using components with known vulnerabilities. So now we kind of get into a little bit of where the Node Security Project comes in for Node applications, and this is more fun stuff than listening to me babble about other stuff. So we've got a tool called NSP that we published. So you can basically do those slides came out wrong. You can basically do npmi-g NSP, and that gives you a binary that you can run. So you can run basically NSP package or NSP shrink wrap, depending on if you use shrink wrap files or package files. And what that does is it actually gives you output that looks like this. It basically recursively goes down your entire dependency tree and looks at every single dependency and compares that against our database of known vulnerabilities and says, is this basically, is this a vulnerable package to something that's known? And it doesn't mean that your project is necessarily exploitable, but it's why not just bother to upgrade if you know about it? So this particular said that the QS package in request 236 is vulnerable and it's patched in this one. So probably you should upgrade your request, or you should complain to Michael that he's using a version that's vulnerable. Doesn't really mean again that you're exploitable. So I'm going to go back to this slide here and talk about requireSafe for just a minute. Basically, requireSafe is this is why I didn't really want to talk about it in depth, is because it would have just ended up being a product pitch. It's basically Lyft's enterprise version of the Node Security Project. So when I said that when I started the Node Security Project, I wanted to sort of a ocean boiling endeavor, right? We wanted to change the perception of security in the community. And it turns out that that's a really hard problem and that it's a full-time job. We said when we started that we were going to audit all the modules in NPM. There's 18,000 modules when we started the project. There's over 125,000 modules now. And that's just an insane task for a small group of 4 people that sort of like work on it to actually accomplish. So what we need to do is we need to make this project our full-time job. And to do that, we need funding. Therefore, we need to basically trick enterprises or businesses into funding the Node Security Project by buying a product that's useful for them. So it's just the whole thing there is it's intentful auditing of your dependency tree, which I'll get into a little bit later when I talk about dependency graphs with NPM. So that's no more salesy pitch. Sorry. So the other thing I want to talk about, another tool that's really useful if you do a lot of front-end development, is a tool called retire. Same thing. We didn't do it. We didn't build it. A guy, his Twitter handle's webtonull. I think his name's, I can't pronounce it. He wrote retire, and it actually uses the node security project data as well, but it also does something else that's cool, and it looks at your dependencies like jQuery and Angular and all those other like front-end libraries to see if they've got known vulnerabilities, and it can tell you, it can give you a very similar view, like the ICANN has bars, whatever. jQuery had known vulnerabilities, and it gives you like some references for you to read about it, but really just go update your dependencies. We did something interesting with retire, and we ran it against the entire Bower, because Bower's like, it's a lot of front end. So we ran it against a Bower, and basically found just a ton of data, and a ton so much that it would be rather difficult to communicate with all the people. So we wrote about it, we sort of evangelized about it, and we put the data up there so that everyone could have that, and so basically look up if they've got something that's vulnerable, just to sort of talk about that. So that's that. Last one is unvalidated redirects and forwards, and so web applications typically like redirect you. You go to hit a URL, you're not authenticated, so it redirects you to the login form and says, hey, log in, and then we'll return you to your old place. A common method to do that is just to put something like a return to URL in the query string or something like that. We see that all the time. It's useful in phishing attacks where I might send you a URL that with a redirect to my domain. It might be useful. Again, it's a low impact vulnerability typically, but it's part of the OWASP top 10. So that is the OWASP top 10 in a nutshell. I'm sure somebody else could explain it a lot better, but that's a great place to start when you're talking security of web applications, node applications. So let's talk about some just things. It says I've got like 3 minutes left, but we'll probably go over just a couple. Basically, this is a question that's been on my mind, and it's sort of the premise behind the Node Security Project and how we got started with that, as well as requireSafe. And it's whose code are you actually running in production? And when you talk about Node, the Node way is to build tiny modules and that do one thing and do one thing really well, and we share all that code. So you can build something off of David's WebRTC Explorer and build on top of that, and not have to do all the work that he did, and we can use it as stepping stones. However, you end up with an interesting problem when you come to security, and that is trust. Do I trust all of you to ship code into production for me, right? You've got your team there, and you've got all the other people, but you might have one bad actor, and not somebody that's necessarily intentionally writing bad code, but they just might produce the shitty module, and it does the thing that you want it to do, but it does so that has a vulnerability in it. Unless you go look at your dependency tree and you actually audit all those modules intentfully, you might not find that it's actually got that problem. And chances are, if you've got a giant dependency graph, you're going to have bugs in there, right? That's just software. So that's sort of been the premise behind all of the research that we've done. And I'm not going to show you who this is and who the module is. Who here has changed their NPM password in the last, let's say, 90 days? None of you. I did, because I asked that question at another conference last week, and I hadn't done it either. And the reason is because when you npm log in, it sticks it in a configuration file, and you forget about it. And so unless when you set your account up and you picked a really good password at that time, it's still that shitty password that you set it up with. And so we did a little brute force against the registry, little unsanctioned work, and I'm not going to tell you what we did, but let's just say weak passwords. And so we found users with weak passwords. And this is getting addressed by NPM to try to improve that. But let's say that we found one account that's really shitty on purpose. So we found one maintainer, and this maintainer's dependency graph. They actually only have, I think it's like 3 or 4 modules that they publish. But then those 3 or 4 modules are depended on by another level, right? And then those modules are depended on. And for some projects, that goes very far. And that reach has large impact, let's just say. So the security of your account and your code actually matters for other people, which I think is kind of interesting. It was very interesting to see what impact those had. So that's that. Issue monitoring. So the last two things I have to talk about have to do with basically. So this one has to do with basic. How can you improve the security of your project or the stuff you ship to production without actually touching any code? So this is like open source intelligence, right? How can we pay attention to what's going on in the community? One might be keeping up with the Node security project, on Twitter and seeing what vulnerabilities we publish, or using requireSafe and getting those alerts. Another way might be just pay attention. I wrote this really horrible application that just scrapes all of the issues. For anything that had a GitHub URL, any project that had a GitHub URL, it would scrape issues every 24 hours, and it just kept track. And it would just full text index those and say, is there any keywords in those issues that might be security related? Put them in a queue, let a human look at them, and then we basically say yes or no. This is good or this is bad. And there's about 5 a day, and if I can keep up with the entire registry, chances are you can keep up with your projects and actually do that intentfully, and it actually has a great impact. We found a vulnerability that was that I didn't know about, that was open for Marked, the Markdown processor, that's still unpatched, and it was open since last October, and just maintained there. A vulnerability in SQL injection, and there's a bunch more that are unpatched that we're sort of trying to work with authors, but they're out there, they're public, people know about them, so you could potentially maybe switch to a different library or something like that, or send a pull request to fix that. And yeah, so that's it. I find it really interesting. Basically what we can do then is we can take the information that we found here and we can spread it to the community. It sucks when security issues get submitted publicly. But it happens, right? Somebody just says this is a security issue, or maybe they don't know it's a security issue, it's just a bug, and so they drop it in GitHub issues, and then it's there for all the world to see. But it impacts you because they're part of your dependency tree. And you might not even know that they're part of your dependency tree because you're using, let's say, 4 modules, but you have a dependency tree of 60 modules. And so it might trickle down from there. So really understand what your dependency tree. The other thing I want to sort of preach about, I guess, is if you fix a security problem in one of your modules, please self-disclose. Please let the community know that there was an actual security flaw to motivate them to update their module. And you can do so by emailing a report at nodesecurity.io or just going to nodesecurity.io and letting us know. And that way we can publish an advisory and it'll be part of NSP and everyone will know about it. Their builds will break in their CI system and they can just update. And the last thing is some Docker stuff I've been doing over the last couple of weeks. So anybody here heard of Rimrafal, a module that was published besides you? Okay, so what's interesting is somebody in Lisbon, which I have yet to meet. I've been here and I'm like, I met them. There's a big situation. So anybody can publish any garbage on NPM, right? You just be like, this module is an MP3 and you can just publish it. And so somebody, and NPM modules have install hooks. So pre-install, post-install, post or pre-remove, stuff like that. But install hooks are very interesting because they're just you npm I, and it runs that code before it installs the module. So if you say publish a module that is rm-rf/star as a pre-install hook, it's going to fuck you over if you do that. So they published that, and then they put it on Hacker News. And the description The description of the module said, don't install this. That doesn't mean people aren't going to freaking install it. So, but it got me thinking, like, it is a problem. How do you do that? There's a -- ignore scripts, I think it is, that you can use when you install modules, which is great for CI systems so that somebody can't just jack your CI system. But for a developer machine, like the first thing I'm going to do is weak passwords plus patching code plus pre-install scripts plus owning a developer, patching all of their modules, publishing those modules, it's going to spread, right? It's a problem with our ecosystem. And so the problem is we can't police it, and you can't stop people from writing or obfuscating code or any of that stuff and putting it into our ecosystem. It's a part of the problem. It's not unique to us. Pip has it, RubyGems has it, Perl has it, right? It's just intentfully malicious. So I thought, how can we actually detect some of this? And I went back to my days at Symantec where we did sort of blended threat type work, where we had like a bunch of ghosted machines, so we could reset the state and we could drop a blended threat like SQL Slammer or Blaster in there and see how it spread, and we could see what it affected on the systems and how it changed them. It turns out Docker's really good at helping at this problem, and this particular feature would probably be very useful to other things as well. And so what I did was I ran this particular module, and I'm actually currently running all of the modules in the registry, and it's probably pretty close to done today, just to see what the baseline is for what they're doing, to see if I could find any other bad actors in the ecosystem. So I ran rimrefall in Docker. And then Docker has this really cool feature, just Docker diff. You just run Docker diff, and it just craps out all of the changes. It just says, here's all of the changes to the file system. Adds, changes, and deletes. And you can immediately see, oh, we're deleting bin, home, lib, etc, root, right? And you immediately see that like this is an extremely bad actor. Now this is not perfect. This is back in the day. This is like shitty antivirus detection, right? But it's better than what we're now watching for this. Please don't publish stuff that's going to be like cause community havoc and whatever intentfully, just to see if we're going to catch it. If you've got an idea, please just send it to us of how you would evade detection of something like this, and maybe we can make it better. It is just antivirus-esque, but it's better than what we had before. And so now we're kind of watching, yeah. So that's basically it. If you didn't learn anything from this presentation, please take some of the knowledge that you have that you already knew about and spread it to a couple of people. That's the greatest. As well as if you learn new things, please spread it to coworkers or friends that might benefit from this. It's the greatest thing that you can do for our community when it comes to security. So, thank you.